Okay, in this review problem, we're going to find a formula for the coefficient of x to the k in the expansion of x plus 1 over k, or x plus 1 over x to the 50th power. So by the binomial theorem, x plus 1 over x to the 50th is equal to summation k equals 0. Now let me switch letters, not use k. I equals 0 to 50. 50 choose I. X to the I times 1 over x to the 50 minus I. Now this can be rewritten as summation I equals 0 to 50. 50 choose I. X to the I times x to the minus 1 to the 50 minus I. Since x to the minus 1 is 1 over x. So that's summation I equals 0 to 50. 50 choose I times x to the I, and now I can multiply here. I get x to the minus 50 plus I, and then I can multiply these two together and get summation I equals 0 to 50. 50 choose I, x to the 2I minus 50. So there's my k, so to speak. X to the k is going to be 2I minus 50. Now what kind of number is 2I minus 50? Well, the smallest it can be is, if I plug in 0, I get 2 times 0 minus 50, so that's negative 50. And I also get, if I plug in 50, I get 2 times 50 is 100, minus 50 is plus 50. So the exponent that I see here must be somewhere between negative 50 and plus 50. So the coefficient of x to the k is 0 if k is bigger than 50 or if k is less than negative 50. If either one of those happen, then that's not going to appear anywhere in the summation because the smallest exponent is going to be minus 50 and this biggest exponent will be plus 50. Also, the coefficient will be 0 if k is odd. 2 times I minus 50, no matter what, that's an even number because I can factor a 2 out of this. That's equal to summation I equals 0 to 50. 50 choose I times x to the 2 times I minus 25. And the exponent here is an even number because I factored the 2 out. Now, otherwise, what happens? Otherwise, my exponent here, if I have k is equal to 2I minus 50, then I can solve for what I would be. So k plus 50 equals 2I, which means I is equal to dividing k over 2 plus 25. So otherwise, the coefficient would be 50 choose I, where there's the I that I just got. So 50 choose k over 2 plus 25, where k is even and k is between negative 50 and plus 50. So there's your coefficients for x to the k as long as these two things are both satisfied. If it's either odd or out of this range, then the coefficient is 0. So that's the answer for this problem for the expansion of what the coefficient of x to the k looks like if this thing gets multiplied out.